functions, linear curves, and parabolas. So we have y equals 3x minus 2. We're also introducing this notation with f of x is 3x minus 2. And we'll come back to that in a moment. Now, we've got various values of x. So starting with x is negative 2, substitute that in here. 3 times negative 2 is negative 6. Take away 2 gives us negative 8. If x is negative 1, that's negative 3 take 2, which is negative 5. When x is 0, 3 times 0 is 0, so this just becomes negative 2. When x is 1, it's 3 take away 2, which is 1. And I can see these are just going up in 3s, so it's going to be 4 and then 7. And the f of x values will be exactly the same. As I said, we're introducing this notation. So if, for example, we want to calculate when x is 2, we just substitute 2 in for x. And we do that here by replacing the x with 2. And we do it over here by replacing the x with 2. And then we can see that that's 6 take away 2, which is 4, which is the value that we got in the table. We now want to plot y is 3x minus 2 and check that the table values are correct. And I'm going to use Desmos to do that. So, we have y equals, we can use the keyboard here actually, so y equals 3x minus 2. And here we have it, we can see it's a straight line. And let's just check some of the values. We can't see all of them, so let's just move the graph. So when x was negative 2, we got negative 8 as the y value, that's correct. And at negative 1, we got negative 5. At 0, we got negative 2, and of course that's a really important point, that's the y-intercept, and that always happens when x is 0. At 1, we got 1. At 2, we got 4. And when x was 3, we got 7. So all of those values work. So we want to know the gradient of the line we've drawn. Well, let's just get the line back. So let's suppose, start here, I go 1 unit across, then I go 1, 2, 3 up. So my gradient is 3 divided by 1, which is 3. But of course we know that because when we have y equals mx plus c, the m is the gradient. So the gradient is 3. The y-intercept, we pointed that out a couple of times, was at 0, negative 2. And again, we can always read that off from here. Find the value of x that makes f of x equal to 0. Well, we know that f of x is 3x minus 2. So if f of x is 0, we have 0 equals 3x minus 2, or 3x minus 2 equals 0. Add 2 to both sides and we get 3x equals 2, and then divide both sides by 3, giving us that x is 2/3. So for y equals x squared minus x minus 2, so this time we're letting f of x be x squared minus x minus 2, and the presence of the x squared here tells us it's not a straight line. Indeed, it should tell us that we're going to get a parabola here. Substitute negative 2 in. So negative 2 squared is 4. Take away negative 2, so that's going to be 4 plus 2, which is 6. Take away 2, that one should be 4. Substitute negative 1 in, so that's going to be 1. Add 1, take away 2, so that one's going to be 0. Put 0 in, and clearly this is 0, so we just get negative 2. Substitute 1 in, and that will be 1, take away 1, take away 2, so that one's also negative 2. Substitute 2 in, and we get 4, take away 2, so that one is 0. And if we put 3 in, that's 9, take away 3, so that's 6, take away 2 is 4. And of course, as discussed before with the f of x, we're going to get the same values, but let's just look at an example. For example, f of 1 gives us 1 squared, take away 1, take away 2. So when we work out f of 1, we just replace all the x's with 1. And that's 1, take away 2, which is negative 2. So all of these values are going to be the same. We now want to plot this and check that our table values are correct. And then we want the y-intercept, the values of x that make f of x 0, and the coordinates of the turning point. So let's use Desmos to plot. So we need to just change this one. So it was x squared minus x minus 2. And here it is. And negative 2, y is 4. At negative 1, we do get 0. And 0, negative 2. And if we come around here, 2, 0. And if we go to 3, we do get 4. So all of those values are correct. So we can see the intercept here, the y-intercept is at 0, negative 2. The turning point is 0.5, negative 2.25. And we can see that f of x is 0, i.e. we cross the x-axis when x is negative 1 and when x is 2. So let's put down those values. The y-intercept we know was at 0, negative 2. Of course, it's always when x is 0, because x is 0 on the y-axis. And of course, if x is 0, this term and this term disappear, just giving us that y is negative 2. Find the values of x that make f of x 0. When f of x is 0, that's the points where it crosses the x-axis. So we found that the values of x, and it just says x here, so we don't want coordinates. So that was when x was negative 1 and when x is 2. And of course we could have got those from the table as well. We know that we had 0 here and 0 here in the table. What are the coordinates of the turning point? Well, we looked that up while we had the graph, and the turning point was at 0.5 and negative 2.25. And something to note is that parabolas are always symmetrical. So if this was at negative 1 and this was at 2, halfway between those, if we take the average of those, that does give us 0.5. So the turning point always will lie midway between these 2 points, where f of x is 0. And then if we just substitute 0.5 into our f, we'll find that we do get negative 2.25, and that's the position of the turning point. We want to evaluate the following. So we have f of x is 20 minus 3x, and we want f of 6. And that means just replace x with 6. So 3 times 6 is 18. 20 take away 18 gives us 2. Here we want g of negative 2, so that gives us negative 2 squared. Take away 4 lots of negative 2, add 10. So that's going to be 4 plus 8, which is 12, add 10 gives us 22. And for this one we want h of 0, so that's going to give us 15 take away 0 squared, which is just 15 take away 0, which is 15. The graph below shows y equals x plus 3 and y is 9 minus x squared. So we're going to let f of x be x plus 3 and g of x be 9 minus x squared. Now x plus 3 is clearly the straight line, the blue one, and 9 minus x squared is going to be the parabola. We want to state f of negative 5. Now we can get that one from the graph. So if we go to where x is negative 5 and go down on the graph here, we can see that that's at negative 2. So we can read it from the graph like so. We could also calculate it. Let's do that and just check that we got it correct. So f of negative 5 would be negative 5 add 3, which is negative 2. So we got the same answer both by calculating and by checking the graph. G of 4, so 4 is here. Then remember G is the red one. So what we're going to be doing there is coming down until we meet the graph again and coming across, and that looks like it's negative 7, but let's check that by calculation. So G of 4 would be 9 take away 4 squared, which is 9 take away 16, which is negative 7. We want the values of x where f of x is equal to g of x. Now f of x is equal to g of x where the graphs cross. So we can see that happens when x is 0. And then we can also see that that happens when x equals 2.